Okay. So, so look at this circuit diagram. So now we are going to solve the circuit using nodal analysis. So finally they asked us to calculate what is the current flowing through the zero point 0.1 ohm resistor. That means Ix using nodal analysis. Okay, as we discussed early, so for solving the problem using nodal analysis, all the voltage, all the sources which are current sources, that should be, before going to solve the problem, we should ensure that is the circuit having the sources which are current sources. Okay. See, look at the circuit diagram. So we have three sources, right? There is one 4 volt, 3 volt, and 2 volt. So these are the voltage sources. So 4 volt plus minus symbol is there, and volt 4 volt is there. So all the three sources which are voltage sources. Okay. For solving problem using nodal analysis, we must have some current sources in the circuit. So before going to proceed with the nodal analysis, first we should convert all the voltage sources into current sources. So already we have discussed how to convert the voltage sources to current sources, and similarly current sources to voltage sources. So now we are going to convert those voltage sources into current sources. Okay, by conversion, so what you will get it. So for example, the 4 volt in series with 0.2 ohm, I am converting into current sources. So this is what the current flow. Why? Because the plus to minus. So the current which is flow from this left side to right side. So the arrow, it is towards left side. Then for current sources, the resistors, it should be connected in parallel with the source. That is very important, right? So in the circuit, the voltage, the current, the resistor which is connected in series with the voltage source. But after conversion, the resistor, it should be in parallel with the current source. So the resistor value, same value, 0.2 ohm. But for the current, I equal to, what is the formula? It is V by R. V value, what is V? It is 4. 4 by 0.2, which is equal to 20 amps. So that is the current value of this current source. Then similarly, we have to convert the another two sources into current sources. So one resistor, it is in series, sorry, in parallel with one source I. So same procedure we have to use it here. So here it is 0.1 ohm, and the current sources I equal to V by R. V is 2, 2 by 0.1, it is 20 amps. So 2 by 0.1, it is 20 amps. So this is your 20 amps. Then similarly for this side, we have one resistor, then one current source it is here. So 3 by 0.1, it is 30 amps. Then resistor value, it is 0.1 ohm, and here it is 0.5 ohm, and here it is 0.5 ohm. Similarly for here it is 0.1 ohm. So this is what the circuit. After the source conversion, we got this circuit. So afterwards only we can start doing the nodal analysis. So again I repeat, for nodal analysis, before going to solve the problem, please ensure that all the sources which are current sources. Right? Later on, then only we can apply Kirchhoff's current law as such. Right? You look at this diagram, we have three nodes here. This is node 1, V1. Here we have another node, it is V2. Here it is another node, it is V3. So three nodes. So we have to apply Kirchhoff's current law in three nodes. We will get three equations. By solving all the three equations, we will get V1, V2. Afterwards, we can calculate what is Ix. Okay, now let me start applying the Kirchhoff's current law for loop 1. So apply Kirchhoff's current law. Apply Kirchhoff's current law for current law in loop, sorry, not loop. If for mesh analysis, we should use the word loop. Here it is Kirchhoff's current law in node 1. Okay. So this is what the thing. So Kirchhoff's current law, we should apply the Kirchhoff's current law for node 1. So the Kirchhoff's current law, what is that? The current, the sum of the current entering to the node, which is equal to sum of the current leaving to the node. So for this node, you look at this node 1. Let me change the color of the pointer so that it will be easy. Okay. So for this node, the current entering the node is this current. It is entering the node, and this current it is entering the remaining all the currents. It is assumed to be leaving the node because the sources which is supplying current and the others passive components is it is consuming the current. So current entering the node is so 20 amps and 20 amps both the current which are entering to the node. So you can write the equation 20 plus 20. Why I am putting 20 plus 20? Because both the current 20 amps, which is entering into the node, but which is equal to the current leaving to the node, current leaving. So for 0.1 ohm resistor, there is a current leaving, and 0.5 ohm resistor, there is a leaving current, and for 0.2 ohm resistor, there is a leaving current. Okay, then for 0.1 ohm resistor, the current I is equal to V by R formula, right? So V1 divided by 0.1. So that is very, very important because the current I equal to V by R. I is V1 divided by R 0.1 for the first component. Plus, then for find 0.5 ohm resistor, we have two voltages. So see the both the end of the 0.1 ohm resistor. One point it is 0.1 ohm, that is V1. Another point it is V2. So V1 minus V2 divided by 0.5. So here we cannot write V1 by 0.5 as like the previous step because we are the resistor 0.15 ohm, it is connected between the two voltages. You might have asked, sir, there may be a voltage at the another end of the 0.1 ohm resistor. Actually, this is maintained at ground potential. It is 0 volts. So V1 minus 0 by 0.1, that is why I have used V1 by 0.1. Okay, so the two component it is over. Now the third component it is 0.2 ohm. You see here the 0.2 ohm it is connected between V1 and V3. So V1 minus V3 divided by 0.2. So this is the nodal equation of the node 1, right? So 20 plus 20, V1 by 0.1 plus V1 minus V2 by 0.5 plus V1 by V3 by 0.2. So you will get by solving it, by you taking LCM and everything. So what is the final equation? You will get it. So 40, which is equal to 17 V1. That I have skipped some steps. It is a basic mathematical steps involved here. So you have to do all the steps. You will get a current. You will get a voltage equation like this. 40, which is equal to 17 V1 minus 2 V2 minus 5 V3, which is equal to, that is equation number 1. Is it clear? So we have to take V1 outside and V1 into 1 by 0.1 plus 1 by 0.5 plus 1 by 0.2. So by you take LCM and everything, you will get the final equation as 40, which is equal to 17 V1 minus 2 V2 minus 5 V3. Okay. Now I am going to apply Kirchhoff's current law. Apply Kirchhoff's current law in node 2. You look at this node 2, we don't have any current sources, right? So all the current it is assumed to be leaving the node. Okay, so current entering the node is 0 because since we don't have any current sources connected to node 2. Directly, no current sources which is connected to node 2. So left hand side it is equal to 0. 0 equal to. So for the previous node, we have put 20 plus 20 because 20 amps and 20 amps, it is directly connected to the node 1. That too, it is both the current which are entering to the node. So that is why 20 plus 20, we have taken it as left hand side. Now, for the node 2, we don't have any current sources connected directly to the node. So it is equal to 0. Now, so for 0.5 ohm, so 0.5 ohm, it is connected between 2 and 1. So V2 minus V1 divided by 0.1. So this is the current equation. This is the current value of this 0.5 ohm resistor. Then for 0.1 ohm resistor, simply it is V2 by 0.1. Similarly, for this 0.5 ohm resistor, it is connected between the two nodes 2 and 3. So V2 minus V3 divided by 0.5. Now take LCM, everything. What you will get it is your final equation, maybe it is minus 2 V1 plus 14 V2 minus 2 V3, which is equal to 0. This is equation number 2. So for node 1, we got this equation. For node 2, we got this another equation. Now, similarly, we are going to do the same procedure to calculate what is the nodal equation for node 3. Now, apply Kirchhoff's current law in node 3. That means at this node. So, okay, now, what is that? So here for node 3, we have two current sources which are connected, right? But you see here current entering to the node, which is equal to current leaving to the node. But here the current entering to the node is 30. Am I right? Current entering to the node, which is 30. Now current leaving the node is 120 amps current. So this current, it is entering into the node. This current, it is entering, it is leaving from this node. So 20 plus. Now this current, it is this 0.2 ohm resistor current. That means this 2.2 ohm resistor, it is connected between 3 and 1. So V3 minus V1 divided by 0.2. Okay, over. Then similarly for this 0.1 ohm, V3, since the ground potential, another end is maintained the ground potential minus 0, that we can leave it. So V3 divided by 0.1 ohm plus for this 0.5 ohm, again V3 minus V2 divided by 0.5. So finally, what you will get is, by simplifying this, so your equation for the third equation you would be getting is minus 5 V1 minus 2 V2 plus 17 V3, which is equal to 10. This is equation number 3. Okay. So for nodal analysis, mesh analysis, the main step is you have to apply the Kirchhoff's current law carefully and to try to calculate these three equations. So since we have 3 nodes, so we are getting 3 equations. If we have some problems may have 2 nodes, we may get 2 equations. Okay. So now we are going to solve these 3 equations using no, that Cramer's rule. We will get the current V1, V2, V3. Okay. So this is what your fundamental procedure to calculate the nodal analysis. Now let me do the matrix, right? So we are writing all the equations in matrix form. So since it is a 3 variable V1, V2, V3, so we'll get 3 cross 3 matrix. Okay. So our objective V1, V2, V3, we need to calculate, right? You look at this, what is the first equation? The first equation, 17V1 minus 2V2, so minus 5. So 17 minus 2 minus 5. That is your first row. Then your right hand side, it is 40. So 17 minus 2 minus 5. Then here we will get 40. Then similarly for the second row, minus 2, 14 minus 2. Similarly for the third row, minus 5 minus 2 is 17, and here it is 0, and here it is 10. Okay. So this is what the three equations. So those three equations matrix form we have written here. Now we have to solve this equation. We have to calculate what is V1, V2, V3. You can apply simply Cramer's rule, right? You have to calculate what is del, what is del 1, what is del 2, what is del 3. Then accordingly, we can calculate V1, V2, V3. So for calculating del, it is 17 minus 2 minus 5, then minus 2, 14, and minus 2, minus 5, minus 2, 17. So to calculate determinant, please kindly use the calculator so that you may not do any careless mistakes. So use calculator to calculate the determinant. So the determinant, what value, what you will get it is, so 3520. Okay, you just ensure the answer. Then similarly for del 1, you will get the matrix, it is 40, 0, 10. Then minus 2, 14, minus 2. Similarly here it is minus 5, minus 2, again 17. So determinant del 1's determinant 10,100. Similarly for del 2, it is 17, minus 2, minus 5, again 40, 0, 10, again minus 5, minus 2, 17. So the determinant value, it is 2,200. Similarly for del 3, our determinant value will be 17, minus 2, minus 5, minus 2, 14, minus 2, 40, 0, 10. Your determinant value 5,300. Now, you see here, we can calculate what is V1. So V1 equal to del 1 by del. V2 equal to del 2 by del. V3 equal to del 3 by del. So you will get V1 2.86 volts, V2 0.625 volts, V3 1.5 volts. So V1, V2, V3 calculated. The problem, it is not over. You see, look, you see the question. Calculate the current Ix. Ix means the current flowing through this resistor, that is your 0.1 ohm resistor. What is the current? V2 minus 0 divided by R, V by R, right? So V2 minus 0 divided by 0.1. So that is the answer. So the current Ix, the current flowing through 0.1 ohm resistor Ix, which is equal to V2 minus another end, it is maintained 0 potential. So 0 divided by R, V by R formula. R, it is 0.1 ohm. So V2 by 0.1 ohm. V2, it is 0.625 divided by 0.1. You will get 6.25 amps. That is the answer. So this is the current flowing through 0.1 ohm resistor. That means at the center. So this is the procedure how to solve the nodal analysis. See, I repeat, the first and foremost step to solve the problem using nodal analysis is convert all the voltage sources into current sources. If the problem itself, they have given some current sources, means don't worry, we need not do any conversion, because the problem itself, it is given current sources, we can start the proceed, right? If they have not given as current sources, then if it is given in voltage sources, we have to convert those voltage sources into current source, then only you have to proceed. So as like the problem which you have solved right now, right? So see here, the current sources is solved into voltage sources converted into current sources. Then we applied nodal equations, Kirchhoff's current law to calculate the nodal equation. By solving all the three equations, we will get the del 1, del 2, del 3. By the way, V1, V2, V3 is calculated. Then finally, Ix it is calculated. Okay, this is a common step. You can apply this step for all the problems to calculate the current or voltage using nodal analysis. Okay, thank you.